The world is a big place, almost 8 billion people and counting. It's easy to think that Earth is everything because it is everything we have ever known. Every experience that we have ever had has only existed within this tiny bubble we've built around the Earth. Our only real concept of the world beyond our own comes from the twinkling stars we see in the night sky. There is an incredibly massive universe beyond our atmosphere, and in this video I'd like to blow your mind with how small we really are. Let's start with Earth, the birthplace of humanity. Every human that has ever lived has lived and died on this planet. Due to its abundance in hydrogen, carbon, oxygen, and nitrogen, life has flourished here. The Earth spans about 13,000 kilometers in diameter, serving as residence to over 7 billion human beings and millions of other animal species. The Earth is just one of 8 planets that orbit the Sun, a main sequence yellow dwarf star that illuminates our sky and the rest of the solar system. As you probably know, the other planets orbiting our star are Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. I said earlier that Earth was a big place, and many of us think it is physically huge, but let's compare it to something like Jupiter. Jupiter is almost 90,000 miles in diameter, making it around 11 times wider than the Earth. In volume, however, Jupiter is over 1,300 times larger than Earth. In fact, the famous red spot on Jupiter is actually wider in diameter than the Earth itself. Jupiter, although successfully dwarfing the Earth, is nothing in size compared to our Sun. At around 860,000 miles in diameter, the Sun is roughly 10 times the width of Jupiter, making it over 100 times bigger in diameter than the Earth. In terms of volume, around 1 million Earths could fit inside the Sun. Now let's zoom out a little bit and take a look at the scale of our entire solar system. We know that one astronomical unit is equal to the average distance between the Earth and the Sun, around 152 million kilometers. The farther out in the solar system you go, the farther the planets are from the Sun. Not only that, there is more distance between each planet the farther from the Sun that you get. At the far reaches of our solar system, we have Neptune, which lies on average 4.5 billion kilometers from the Sun, or 30 astronomical units. Meaning if you multiply the distance between the Earth and the Sun by 30, you'd roughly have the radius of Neptune's orbit. The question of our solar system's size is a challenging one, primarily because there is not an agreed upon outer limit. Some argue that our solar system ends slightly beyond Neptune, while others say it goes on much farther. Depending on how you see it, and if you're including things like the Kuiper Belt, the Oort cloud, and potential exoplanets and dwarf planets, the solar system could be anywhere from 100 astronomical units in diameter to well in the thousands. This might seem pretty massive in size, but let's not forget that practically every star we see in the night sky is another solar system. NASA's Voyager 1 was the first spacecraft to ever leave our own solar system, which it did in 2012 after about 35 years. Its current speed is around 17.3 kilometers per second. Even with this speed, the question of reaching other solar systems is a challenging one. Think of it like this. If you were to take any city in the world, chances are you could walk the entire length of the downtown metro area in a reasonable amount of time, maybe anywhere from a half hour to a few hours depending on its size. But if you were to try to walk between two cities, say from New York to Miami, that's just an immense distance to cover on foot. And the same exists with stars. Stars with planets are fairly centralized areas because of the orbit paths that the planets are following. However, when you start to measure the distance between individual stars, the distances become rather absurd, and this is where we introduce probably the most common form of length measurement in space, the light year. Our closest neighbor system is Alpha Centauri, located roughly 4.2 light years away from our own solar system. We know the number of kilometers within 1 light year is about 9.5 trillion, so this would mean that Alpha Centauri is roughly 40 trillion kilometers away from us. According to NASA, at the current rate the Voyager 1 is traveling, at 17.3 kilometers per second, it would take 73,000 more years to reach this system, and this is our closest neighbor that we're talking about. Alpha Centauri is a trinary star system, meaning instead of just having one star like our own solar system, it has 3. If any system besides our own would be the first to visit, Alpha Centauri would be the most likely candidate. This is merely one star system though, and the number of total star systems around us is just incredible. Now let's zoom out a little farther. So far we have shown 2 solar systems, Alpha Centauri and our own. The distance between these systems represents trillions of kilometers, yet these are merely 2 specks of dust when you zoom out even further. If we take a look at 50 light years in any direction from our solar system, we get this. This only shows the brightest stars, however, as there are likely over 1,000 stars, mostly being red dwarfs, in this 50 light year radius from the Sun. These stars represent a large portion of the night sky visible to the naked eye. Some of the most well-known stars within this radius are Sirius, Arcturus, Vega, and Pollux. If you think this is an incredible amount of stars, let's zoom out even more. Take a look at this tiny circle here. This tiny circle is the picture we were just looking at, all those thousands of stars taking up a minuscule portion of this picture. This circle represents 950 trillion kilometers and thousands of stars, but it's no more than 0.1% of the galaxy in which it resides. Here lies our galaxy, the Milky Way. Practically every visible object in the night sky lives within this galaxy. Scientists estimate that there are anywhere between 100 billion and 400 billion stars residing in our home galaxy, our Sun being one of them. Just how big is the Milky Way, though? From one end to the other, the Milky Way spans approximately 100,000 light years in diameter, 6.3 billion times the distance between the Earth and the Sun, 1 quintillion kilometers. If you need something solid to back that up, 1 quintillion consists of a 1 followed by 18 zeros. Using the Voyager example from earlier, it would take the Voyager approximately 1.7 billion years to traverse the entire diameter of the Milky Way, traveling at 17.3 kilometers per second. The Milky Way is our home, yet it is so massive that we currently only know so much about it. With potentially a few hundred billion stars, how many billions of planets may even exist here? There's so much unknown about our own galaxy that we can only speculate all that lies within it. Although we have shown numbers to demonstrate the sheer size of the Milky Way, for many people the scale of distance or length is incomprehensible, but it doesn't stop here. Before we move on to the next factor of cosmic scale, it's important to mention other galaxies around the Milky Way. Our closest neighboring galaxy is the magnificent Andromeda. At around 200,000 light-years in diameter, Andromeda is essentially double the size of the Milky Way. It's the closest galaxy to us, but it is located at a staggering 2.5 million light-years from our host galaxy. In around 4.5 billion years from now, Andromeda and the Milky Way will collide in a spectacular fashion and merge to create a giant elliptical galaxy. Another galaxy to take note of is the Triangulum galaxy. Triangulum is located around 2.7 million light-years away. Between the Milky Way, Andromeda, and itself, it is the smallest galaxy at 60,000 light-years in diameter. The Triangulum galaxy is thought to have previously collided with Andromeda and is currently considered to be a satellite or companion of the Andromeda galaxy. Now that we're on an intergalactic scale, let's kick it up a notch. What if I told you that everything you see in this picture is not a star, but an entire galaxy? Galaxies, as shown earlier, can vary dramatically in size. Take Malin 1 for example. Little is known about this galaxy because of its sheer distance from us, over a billion light-years away. What we do know, however, is that this galaxy may be upwards of 600,000 light-years in diameter, making it 6 times longer across than the Milky Way. Although we are used to assuming that all galaxies look relatively similar, not all galaxies are spiral galaxies. IC 1101, an irregular elliptical galaxy, is the largest known galaxy in the observable universe, spanning anywhere between 2 million and 6 million light-years in diameter, containing possibly over 100 trillion stars. Galaxies are the makeup of the universe, but how do we organize them and know how many there are? That's where galaxy groups come into play. Galaxy groups serve to categorize where galaxies lie in the grand scheme of the universe. The Milky Way, Andromeda, and Triangulum are the 3 largest galaxies within the local group, a galaxy group that consists of over 50 galaxies, most of them being dwarf galaxies. The local group is 10 million light-years in diameter. To put this in perspective, the diameter of the local group would be equal to 630 billion astronomical units. With this level of classification and beyond, we're talking quintillions in terms of kilometers. Just like we are able to compare our solar system to its neighboring systems, we can relate galaxies neighboring each other on a much more massive scale. Surely galaxy groups have to be the highest level of cosmic classification, right? Let's go a step farther. Consisting of over 100 galaxy groups, including our local group, the Virgo supercluster is 110 million light-years in diameter. Superclusters are exactly as they sound, a group containing galaxy groups of its own. Just as a galaxy group contains galaxies, a supercluster exists at one level of classification higher, containing tens or hundreds of galaxy groups. The Virgo supercluster, which is home to the Milky Way, is one of about 10 million superclusters in the observable universe. The massive Virgo supercluster is part of an even larger entity, the Laniakea supercluster. It houses over 100,000 galaxies within a diameter of around 500 million light-years. Superclusters such as this one are some of the largest entities in the known universe. The Laniakea supercluster houses the Virgo supercluster along with multiple other superclusters. It is essentially a supercluster consisting of superclusters. It would take the Voyager somewhere between 8 and 9 trillion years to travel across the entirety of the Laniakea supercluster, a time window exponentially longer than the age of the universe. Astronomers have observed that galactic superclusters sometimes form structures that are worth observing. These are mostly observational and don't hold much value in terms of size classification, but structures such as voids and walls exist within our universe. The Botas void, for example, is an immensely empty region of space that spans over 300 million light-years in diameter. Galaxies still exist here, but they are few and far between. The Hercules Corona Borealis Great Wall is another one of these structures, and is considered to be the largest structure in the known universe. It contains billions of galaxies and spans up to around 10 billion light-years across. Space holds many voids, walls, superstructures, and superclusters that come together to make up our known universe. And here we have it, the observable universe, the highest known level of cosmic classification. Everything we know, every inch of matter, exists here. The observable universe is estimated to be around 90 billion light-years in diameter. Current estimates suggest that there could be anywhere between a few hundred billion galaxies and a few trillion galaxies residing in the observable universe. The complete size of the universe is heavily disputed. We know roughly how large the observable universe is, but we have absolutely no idea how big the full universe may be beyond what we can see. Is our observable universe just a speck of dust to the actual universe? Could there be a multiverse? Put simply, we define the universe as the entity that encompasses everything we know. To be truthful though, we don't fully know what the universe is. In a broad sense, it is everything, but that everything could potentially be part of something even bigger. Maybe the everything we think exists is only a tiny fraction of the real everything. Before we wrap this up, let's do one final calculation. If the Milky Way is approximately 100,000 light-years across, and the observable universe is 90 billion light-years across, that would mean the Milky Way, our home galaxy, makes up a measly 0.00011% of the diameter of the known universe. Keep in mind that the majority of our night sky exists within the tiny circle we showed earlier, which is a tiny fraction of the 100,000 light-year diameter of the Milky Way. In this sense, we can say that the view we have of stars in the night sky is practically a millionth of a percent of the observable universe. In summary of Carl Sagan's most famous quote, "The Earth is a tiny dot containing everything every human has ever known. We are a mote of dust suspended in a sunbeam." I hope after watching this video, you may now see just how incredibly massive the universe is. Our Earth is but a speck of dust within our solar system, our solar system a speck of dust within the Milky Way, and the Milky Way a speck of dust within the grand scheme of the universe. Thank you so much for watching. If you enjoyed the video or learned something new, be sure to give the video a thumbs up and subscribe. I'd love to grow my channel more to reach a wider audience, so your help goes a long way. If there is any content you'd like me to cover in the future, please feel free to comment down below. Until then, I'll see you next time.